All right, as we go on, I mentioned this site before, and this is another thing you may want to take a look at. It's called csharp.net, and they've got tutorials, and you have to do some work, copy it to a Word document or whatever. It says you can download this as a PDF, and you can, but they want you to pay for it. So if you don't want to do that, you can just go out to the site here and kind of peruse your way through this. You know, it's got a bunch of pages to it. There's abstract classes, which we haven't talked about yet. You get ads in here, as you can see. More abstract classes. So there's a lot of examples in here. All right. And again, you know this. This is not the only one there is. But I've looked at some of the stuff before from C#net, and it's not bad at all. So that's it if you want to take a look at that. All right. So we left off on the bottom of page 448, understanding implicit reference conversion. So I'm going to jump back in. All right. Now notice I am going to read. The author says every derived object is a specific instance of both a derived class and the base class. In other words, a dog is a dog and it's a mammal type of an idea. And it says you can assign a derived class object to any of its superclass types. When you do that, C# makes what's called an implicit conversion, really an implicit reference conversion. All right, and what they're saying is it's kind of like casting, which we've done in the past. Not exactly the same, but it's very similar. I would say that it either implicit conversion or implicit reference conversion, one, the other, or both are on your test. I don't remember which ones. All right, and again, the author gives you an example of this on 449. The object class, which starts on page 450, and we talked about this before. If you looked at a class hierarchy, if we looked here and we said, oh, the top object is employee. Employee doesn't have, no, it really doesn't. There really is another object up above here that's called object. That's kind of the parent that's up at the top. All right. Again, I don't know how much experience you've had working with Windows and DOS, but it's kind of like the root, for lack of better words. It's at the very top. And they say the keyword object is an alias for the system.object class. I believe that question is on the test. All right. So object is an alias for system.object. And I don't think they really show too much in here with using object, except, and this is the next several pages, this is the bottom of 451. Since everything is a descendant of object, object provides these four methods that you see on the bottom of 451, and they're explained on the next several pages. The first one is equals. You can use equals to see if two objects are equal to one another. We're not talking about an equal sign or an equal sign or whatever. We're talking about a method that's called equals that you can use to show if two objects are identical. When you create an object, all right, something gets created in one of the background files, a system file that's called a hash code. So each object gets its own unique hash code. So not only is there an equals, there's a get hash code that you can use. All right. There's a get type. So for instance, if I had dog and underneath it I had terrier, let's say, and I said get type, it would show me dog because terrier is a type of dog. All right. If I did it on dog, it would be under mammal or whatever was the parent above it. So that's what you can do with that. The toString, you've been using that. You've used that several times before. But whether you realize it or not, toString is a is an actual C# method. So when you call toString, you're used to just converting something from a number to a string or whatever. But you can override the entire toString method, so when you call toString, you can make it do whatever it is you want it to do. And these four things are discussed starting on page 452, and it goes, we're going to talk about them, but it goes for the next about 4 pages. So again, as mentioned on the top of 452, the getType method returns an object's type or class. All right. So if we created an employee object that was named SomeWorker, and you wrote SomeWorker.getType, if SomeWorker was of type employee, employee is what would show. Now you might look at that and just say to yourself, I get that, but why would you ever use something like that? In the mainstream of things, if you are working for a company, you may have hundreds, potentially thousands of different classes. And you might not know, because somebody just named their object and they gave it a bad name, what kind of object it is. Who's its parent? What type of object is it? So you can call getType on it to find that out. And that's what the author talks about right here. The toString is what I mentioned before. As it says, for example, when you use the object class as toString with an object that you create, it simply returns a string that holds the name of the class. So if you call getType or you call toString like this, they both would return employee. But you can override the toString method to have it do whatever you want. It's interesting, maybe not to you, but in Java, if you call toString like this, it doesn't return the type. It literally returns a hexadecimal number, which is the area in memory where the object lives. That's what Java does. But C# doesn't do it the same way. So again, if I overrode the toString method, then anytime I call toString, instead of just doing the conversion, it would do this. So I can override the toString method to make it do anything I want it or need it to do. All right. The equals method, notice what it says. It says it compares two objects for reference equality. What does that mean? That means if I create two objects, so let's just say I make object 01 for object 1, and I make object 02 for object 2. And they have the exact same stuff in both. They're identical to one another. If I do the equals method, it comes back false. Because this might be at location 1000 in memory, and this might be at location 5000 in memory. When you do equals on two different objects, or two objects, what the system does is it says, do they both point to the same area in memory? If they do, return true. If they do not, return false. That's exactly what it says. And if you want her verbiage, middle of page, 453. And again, gives you another example here on 454. What's so nice about the way that she writes her book is she explains something, and then she typically gives you an example. Sometimes it's a code snippet. Sometimes she just actually shows you a full-blown example. And then that get hash code, as it says, when you override the equals method, you should also override the get hash code, because equals uses get hash code to see if the two objects are indeed equal to one another. If you want more on a hash code, it's on the top of page 555. All right. And the author says, if you don't do what they just mentioned, this is the bottom of the page, says if you write an equals method and you don't override get hash code, it'll still work, but you'll get a warning message, which will tell you, hey, bad things can potentially happen because you did part of what you were supposed to do, but you didn't do all of what you were supposed to do. All right. jumping up to page 456, working with base class constructors, the author says here, when you create an object, you call a constructor that has the same name as the class. Makes sense. All right. It says when you instantiate an object that is a member of the derived class, the constructor executes first. But what you have to realize is if I call a constructor for this, so if I call a constructor, if I create a new commission object, what the author is saying is first, it's got to call the constructor of the employee. And it has to do that because I might have to assign some stuff in the parent before I can go into the child. And that's what the author is talking about. All right. So the author says, so far in the examples that you've seen, each class had default constructors, but that's not usually the way it's going to be. So the example, as it says, they've got an abbreviated employee and commission employee classes in figure 1027 that's on page 457. And the author says employee contains just two fields in a constructor. Commission employee descends, or it's a child of employee, and it has its own constructor. All right? So, look at the example. There's an employee. It has an ID number and a salary, okay, and that's all we have is just that. Then we've got a commission employee, and we've got just that. All right? So the author says that when you create the commission employee, what's going to happen is, first it's going to tell you that it's going to call the base constructor, so the parent's constructor. And in that parent's constructor, that's where we had this. All right, you can see the order in which it happens. Again, that's a little confusing. Read the chapter, please. Sometimes when you work with this, base constructors, as they mentioned there, require arguments. This is what I just mentioned. So imagine in here, all right, what we're saying is, for this, once we create a commission object, it needs to get the ID number and the salary up here. So it needs to call that constructor so it can get these things. All right? And that's what the author shows here. Okay? So what this says is, call the constructor of the parent and pass in this value and pass in this value. Okay? Java does it in a similar way, not quite like this. In Java, you would have said this, but you would have had extend something, and you would have said super dot something equals super dot something equals. But the ideas are the same. Again, in her You Do It, that's on the bottom of page 459, she continues on with this car demo program, all right? And gives you another example. So again, I can't say this to you too many times. If you're struggling with the stuff that we're going over right now, all right, I would strongly suggest that you go and take a look at the examples that are in the chapter, the You Do It's, all right? And it's one thing to just sit there and open them up, but it's another thing to key them in if you don't understand what's going on. All right. 461 begins the talk about abstract classes. An abstract class is a class that is not instantiated. Did you hear what I said? An abstract class is a class that is not instantiated. So for instance, let's say that I was writing an application for a bank, and I created something that was called bank account. So I created a bank account, and I said all bank accounts will have in there a type of account, a person's first name, a person's last name, etc. All that good stuff. All right? And underneath that, I might say, now I have a checking account. and I have a savings account. All right, and under checking, I'm going to just put IB, an interest-bearing checking and a non-interest-bearing checking. Does that make sense to everyone? I'm showing you a 3-level hierarchy. Level 0, level 1, level 2. All right? But the reason I'm showing you that is you would never actually create a bank account object. It's too generic in nature. This would be an abstract class. This would probably also be an abstract class. All right? Because if you tell somebody you're in a checking account, that's not enough information. So again, the higher up the hierarchy you go, the more abstract the classes you'll have. The lower down you go, the less that you'll have. All right? And an abstract class is a class that cannot be instantiated. You have to put the word abstract in it. You'll see that in just a minute. The opposite, all the other classes that we've looked at in this period, they have been non-abstract. So sometimes a class, when it's not abstract, it's called a concrete class. All right, I don't know if the author mentions that in this book or not. I don't remember. All right. Well, I guess if I'd looked down a paragraph, I'd have found, yes, the author does mention it. All right. Yeah. Oh no, I've read the book. I've read the book several times. All right. Again, abstract classes. Get rid of this. Abstract classes, the author says, are like regular classes. They can have data fields and they can have methods, but they cannot be created using a new operator. It provides a base class. It provides a starting point. All right? Abstract classes usually contain abstract methods. They can contain either abstract methods or non-abstract methods. So what's the difference? An abstract method doesn't have a body to it. You're going to see it in just a minute. All right. When you create an abstract method, you provide the keyword abstract and the intended method type, name, and parameters, but you do not provide statements within the method. You do not even supply curly braces. When you create a derived class that inherits from it, you must use the word override in the method header. And again, very similar type of examples to what I've mentioned to you before. This is on 462. The author says, for example, suppose you want to create classes to represent different animals. You might create a generic abstract class called animal that holds everything that all animals have in common with one another. All right? And they give the example like speak. But then when you come in and you do the dog and the cat, the speak will be different. So you will override it. So if we look right here, notice what this looks like. Any method that, notice the class must have the word abstract before it. No public, no private, the word abstract. All right? Also notice that this stuff right here, this is non-abstract. How do I know if a method's abstract? If the method's abstract, it has the word abstract in it. If you put abstract methods in a class, the class must be abstract. Did you hear that? Because I've seen people do that. My program doesn't work. I've got this abstract method, it's giving me an error here. Well, you didn't make your class abstract. So abstract methods can only live within abstract classes. All right? But notice when you put that in, you just put public abstract, the return type, the name of it, in parentheses. That's it. No code. So as it says, that animal class is declared to be abstract. So you can't say animal something equals new animal. Won't work. You create an abstract class like animal, as the author mentions here on 462, because you want to extend it. Now, since this method right here since this method right here is in that abstract class, if I'm going to use the abstract class that you created, I must provide that method. Did you hear what I said? Again, remember we talked about this before. The acronym API, Application Program Interface, and I said it's like a contract. An abstract class is like a contract as well. And what it says is, oh, I'm going to provide this framework for you, but anything that I define in there as an abstract method, you must redefine in your class. So if I say something is going to be based off of animal, it must have its own speak method and it must return a string. Woof, bow, wow, meow, whatever it is. Doesn't matter. And the author shows that. Notice. All right, and since it said abstract, you're overriding it, so you again must use the word override. These examples are shown on the top of page 463 and on 464. Now this is one way you can do it, and they also show you on 464 another way that this can be done. So you like this or like this. All right, the good news is we're almost to the end of the chapter, and like I said, 2 more topics, and we're done with the chapter. The first is interfaces. All right, and I was talking to Colin about this before, but I want to say it again. If you look at the example that we have, in fact, we can use the one up here. If you look here, unlike inheritance that you have biological inheritance, we can only have single inheritance here. So this means that any class can only have one direct parent. Did you hear that? That's the way that C# works. Java works that way. So let's pretend for a second that we created a new kind of bank account. And that new kind of bank account was called checking-savings. And what we wanted to do was we wanted to be both this and this. You understand what I'm saying? You cannot do that. A child class cannot have 2 direct parents. It's not allowed in most object-oriented programming languages. Now, in some of them it is. C++ lets you do that. What you get when you do this is what's called the diamond effect. When you draw it out, it ends up kind of looking like a diamond. So that's not legal. But what if I wanted to do this? I mean, could I do it? The answer is yes. But I don't make it a class. I would grab one of these and maybe make it a direct descendant, or I can create what's called an interface. And an interface is like a class, but it's not a class. All right, and I don't know, maybe that was sound like a dumb statement. But the author says right here, again, the ability to inherit from more than one class is called multiple inheritance. It's a difficult concept that can lead to a lot of confusion, so it's prohibited in C#. However, in C# you can have multiple interfaces, just not multiple class inheritance. So an interface is defined here on the top of page 466, and that's on your test, as a collection of methods and perhaps other things that can be used by a class as long as the class provides a definition to override the interface abstract definitions. Again, that's a lot of verbiage, but I go back to what I just mentioned to you before. The acronym API stands for Application Program Interface. The I means interface. And I said it's like having a contract where you can use the stuff that's provided, but you have to agree to use it in that way. You know, when I moved into the apartment that I'm in right now, I had to sign a lease. And it said that there were certain things that I wasn't supposed to do. Some of them were specified, some of them were not specified. All right? For instance, you know, I've never used it, but there's a garbage disposal in the apartment. All right, but they did talk to me about things like this. For example, let's say that I had a piece of furniture I didn't want anymore. I'm not supposed to try to shove it into the sink and into the garbage disposal. All right? So there's certain things that are supposed to be used in a certain way. That's what an interface is. It defines certain methods that you are supposed to use. What it does is it allows you to do something similar to multiple inheritance without actually having multiple inheritance. You are inheriting interfaces as opposed to inheriting classes. One more statement that just to confuse you just a little more. So C#, like Java, allows for only single class inheritance, only one parent. C#, like Java, allows for multiple interface inheritance. All right? So that's the difference between those. And the author says you actually started learning about these in the last chapter because that comparable that we used in the last chapter was an interface. So you define it, but notice the word here. You don't use the word class. Public interface. All right? Most of the time, although it's not mandatory that you do this, most of the time when you create an interface, you start it with a capital I. All right? You just do. That's just kind of convention in any language. I for interface. It's not that you have to do that, but again, it's just become convention over time. So the author shows you this example here on 467. So notice class employee colon again, all right, I workable. But now what you're doing is you're not showing inheritance, class inheritance, you're showing interface inheritance. Now just to show you, in Java, when you're doing inheritance, you use the word extends. When you're working with interfaces, you use the word implements. But here you use the same symbol for both. Why? I don't know. Because whoever created the language decided you were going to use the same symbol for both. But the point is that if in here I said you need to have this thing called work that returns a string, that means that anybody who does the iWorkable, all right, needs that public string work, and you got to return a string. So you have it in employee, you have it in animal, you have it in cat, all right, etc. And again, you might find this verbiage that the author uses here maybe more understandable or less understandable, but if you look, this is on 468, right underneath figure 10-39. Abstract classes and interfaces are similar because you can't create objects from either one. But abstract classes differ from interfaces because abstract classes can have non-abstract methods. But all methods within an interface must be abstract. And remember, only single class inheritance. Notice if you look up here, parent would be class. So child is class child would inherit from parent, all right? And those would both be interfaces that it would inherit from, okay? And the last thing that's discussed in the chapter, starting on page 470 and going on to the top of page 473, all right, so the last thing that's discussed in here, extension methods. It says you write a C# program, sometimes you wish that there was a class out there that does almost everything you want it to do, but not quite everything. All right? So it says if you created the original class, you could go back to it and add something new, or you could derive a child class from an existing class. All right? Sometimes it says classes that you want to use are created by others, and you might not be able to directly change them. You might want to change them for what you're doing, but you can't directly change them. That's why you use extension methods. Now, this may not mean much to you, but it says here extension methods were introduced in C# 3.0. What that means is they're fairly new. All right. Programmers sometimes define classes as sealed within the class header. If a class is sealed, it cannot be extended. I think that sealed class is on your test. So you may want to dog here or whatever you do to that on page 470. So they show you an example here where you could come into an existing class and add your own method to it. And I don't want to go into it any more than that. I'm not going to force you to do anything with it. All right. But the example is shown on 471 and 472. Then, as the author has been doing in the last couple pages in the chapter, recognizing inheritance in GUI apps and recapping the benefits of inheritance. The author says, when you create a Windows Forms app, you automatically use inheritance. Every form you create is a child of the form class. We've only had our C# GUIs have only had one form, but we could have as many forms as we wanted or needed to have in a project. All right.
What's the order on that?
What's
Go through different forms, like from one to the next?
if it depends on how you do them.
I'm thinking
All right.
like an installation or something like that.
Well, do you remember the first day in class that what we did was we created that real simple form that had 3 buttons on it, red, white, and blue, and you click the button? Well, what we could have done is we could have had a form when we started the program. We could have had red, white, and blue buttons on it, and every time you click the button, you went to a new form that was of that color.
So like a next button or something?
Yeah, kind of similar to that, yes.
Yeah.
And when you set it up, you can have a form that's in charge, or you can have all forms at the same level. So it's up to you as a programmer. I don't know if I'm answering your question, but it's the only way I know how to answer it. Okay? Usually the forms would be at the same level. It doesn't have to be that way, but normally it works that way. Otherwise, there's a lot more code that you have to typically write. But you can have one form create another form too. You can do that. It's totally legit to do that. All right. So it says forms are of type container control. Container control are of type scrollable control. Scrollable control are of type control. Control are of type component. Component are of type Marshall by Ref object. And Marshall by Ref object are of type object. So what it's saying is those simple little forms that you created are 6, 7 levels deep in the hierarchy. And it's done like that for a lot of reasons. They mentioned on the bottom of 474 and going to the top of 475, derived classes save development time because a lot of the code's already been written. Derived classes save testing time because a lot of it's already been tested. Programmers who create or use derived classes already understand how those work. Finally, when you create a derived class, the base class is not changed, so it maintains its integrity. Let's quickly, this is the last thing we're doing today, let's go and look at the review questions that are in your book on pages 478, 479, 480, 481, and 482, the 20 questions that are there. All right, number 1, specific types of objects assume features of more general classes. That's what inheritance is. I guarantee you there will be 1 or more questions on the test that are a form of this, that ask you what inheritance is. So number 1 is C, inheritance. Number 2, which of the following is not a benefit of inheritance? And the answer is You save computer memory because you create objects, so storage is not required. That's not true. You do save time, we mentioned that earlier. You do reduce the chance of errors, and you make it easier for somebody who already understands the parent. So number 2 is D. That's what you don't get from inheritance. Number 3, a child class is also known as an extended class. It's not a base class, that's the parent. It's not a super class, that's also the parent, or the grandparent, or whatever. It's not a delineated class. I don't even know exactly what they mean by that. So number 3 is,
Derived class, correct?
a child class is also called a derived class, yes. Number 4, assuming that the following are well named, which of the following would be a parent class of house? Well, let's just put this on another page. All right. Well, a house is a type of building, right? So building would make sense for the name of a parent class. So number 4 is B, building. Number 5, a derived class usually contains more fields and methods than its parent. All right? It wouldn't be fewer ever, because it's got everything the parent has, but it's got its own stuff. So that's why it's usually more. So number 5 is A. Number 6, when you create a class that's an extension of another class, you use the colon between the derived class and the parent and the base class, or between the child and the parent. All right, however you want to word that, it's a colon. Number 7. Again, she puts a lot of questions in here like this that I just don't read very well, but she does them anyway. So number 7 is A, mygarden.with. I'm not going to say anything more about it than that. It'd take me a year just to read the question. Number 8, when a parent class contains a private data field, the data field is A, hidden in the child class. So number 8 is A. Number 9, when a base class and a derived class contain a method within the same name and parameter list, and you call the method using the derived object, C, the derived class overrides the base class. Remember, if you want to call the parent, it's base dot. But if you just call it, otherwise it chooses the child name. So again, number 9 is C. Number 10, which is the English language form of polymorphism, and it's both of them. Again, why would she put questions like that in there? I don't know, but she does. So number 10 is C. Number 11, when base and derived classes contain a method with the same name and parameter list, you can use the base class method with the keyword C, base dot. And the IntelliSense should pick that up when you say base dot. It should know what you're trying to do. Number 12, in a program that declares a derived object, you can A, assign it to an object of its base class type. 12 is A. 13 is D. The root base of everything else is D, object. Number 14, it's C. ToString is a class method of object. Equals is a class method of object. Get hash code is a class method of object. Print is not. So number 14, the one that's not right, is C, print. (15) When you create any derived object, the answer is B. The base class constructor must execute first, then the derived. Don't ever say C. It's parent first, then child. They can't, it's not possible for them to execute simultaneously, and they both do execute. So A and D make no sense. B and C are opposites of one another. Number 16, when a base class constructor requires arguments, then each derived class A must include a constructor. So number 16 is A. (17) When you create an abstract class, A, you can inherit from it. You can't create concrete objects. Abstract means it's not concrete. Number 18, when you create an abstract method, you must provide the keyword abstract. You don't use the word class, you use abstract. Number 19, within an interface, A, all methods must be abstract. That's not the way it is in an abstract class. That is the way it is in an interface. So all interface methods must be abstract. Some, most, or all methods in an abstract class would be abstract. Finally, number 20, abstract classes and interfaces are similar in that A, you cannot instantiate, so you can't use the keyword new with any of them. All right? I'm going to look tonight when I get home, and I'm going to look at least a couple of these. All right? But what I'm looking at right now is probably we're going to do 2 of these tomorrow. Okay? And again, what I'm going to end up doing is giving you the hard copies. One of them you'll have to key in, and one of them you'll have to, it'll be like where there's an A, B, etc. type of thing. Plus, I'm going to probably give you one more, and I have to look at the debug exercises because I don't know what they are. All right, so we'll do that tomorrow. That'll probably take about half the class, maybe less, I don't know. The rest of the period will be lab, all right? And I don't know, it's up to you. We can either, you can have your written test for Chapter 10 on Friday, or you can have it early next week. All right, I'll ask you tomorrow what you'd rather have. All right. But I guess we could do that. Do you want to do that today? Do you want to go over the test review? All right, then we can get that out of the way. Let's take a break first. Let's come back. We'll come back at 11. I'll make it 11:10, and we'll try to see if in a half hour or so we can do that, and I'll bring that up right now.